Hello, future math teachers. We're going to continue on with Domain 1. Again, my name is Brent Bauman, and we're going to look into a few examples that cover this section of Domain 1, which is understanding mathematical communication, connection, and reasoning. So you can see from below that, there's a little more detail on the topics that will be covered here. So this gives you a good idea of areas to study, look up, make sure you know definitions, examples, those types of things. So on our first example here, we're dealing with the bottom one where we're dealing with historical information. So you have some mathematicians down here that you need to connect to the situation that's given. So it says, which of the following made the discovery that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides? So this is your a squared plus b squared equals c squared when you're dealing with your right triangle. Not a perfect right angle there, but so hopefully you remember that Pythagoras is the one that came up with the Pythagorean theorem, which is what is being described here. So again, you want to go through some important individuals and make sure you understand key concepts that they either discovered or worked with so that you can answer these types of questions. So a little bit of your history class. Okay. Let's look at deductive reasoning and inductive reasoning. And I put some little definitions up here just to help us remember. So remember when we're dealing with inductive reasoning, this is making a generalization or prediction based on patterns observed in the data. And so we're looking for larger data sets to make it stronger, more reliable conclusion. Deductive reasoning starts with the general principle and draws a specific conclusion from it. So you are using facts to predict something that will happen. It wouldn't apply here because we're not starting with a general theory or applying it to a specific cases. So let's talk about that and show why it doesn't work here and why this one does use inductive reasoning. So what approach is the most appropriate for the following example? So you observed 1,200 food deliveries. All of them experienced delay, which is in line with your theory. However, you can never prove the next delivery will also be delayed. Still, the larger the data set, the more reliable the conclusion. So it's telling us that we're observing something. Okay, so that's a good sign. And we're going to draw a theory, but it tells us also that it's not going to prove that it's going to happen for sure. So it's what we assume will happen, but it's not something we can guarantee will happen. It's telling us that the larger the data set, the more reliable the conclusion. So this is all leading us to inductive reasoning. So again, going through, remembering the difference between the two, identifying them, practicing those concepts will be helpful. Okay. One more is being able to identify what type of function would be needed to fit a situation. So you have your options, quadratic, exponential, linear, constant. So you should have a pretty good idea of the general setup of all of those. And so then you want to look at your situation, try to set up a function to represent your situation, and then match it to the function that it belongs with. So in this one, we're identifying, so the best pizza around offers you a cheese pizza for $10.99. Each additional topping costs $1.25. So there's an extra charge. There's a flat charge of $10.99, and then we have an additional charge of $1.25 per topping. So you could write something as the cost equals, we'll start with $10.99, and we're going to add a cost of $1.25 per topping. So let's use T. So we could rearrange that to give us the cost equals $1.25 per topping plus $10.99. So hopefully what you're identifying here is this is set up as linear. We have y equals mx plus b. B is that starting cost, that flat cost there. And then the m, our rate here is the 125 per item. So this would be considered a linear function. So again, just to give you an idea, make sure you know the setup of all these, the general form of all the functions, and look through different examples that would fit those situations so that you can match them up together. Okay, hopefully that was helpful going through just a few more problems with you and giving you ideas of what you need to go back and look at and study a little more. Have a good day.